Hi, I'm Fatima and today I'll be talking about a key topic in networking, IPv4 versus IPv6, their differences and how we're transitioning from one to the other. So what exactly is IPv4 and why did we need to move on? IPv4 is the fourth version of the Internet Protocol introduced back in the 1980s. It uses 32-bit addresses which gave us around 4.3 billion unique IP addresses. At the time, that seemed more than enough. But as the internet grew and with the rise of smartphones, cloud services, and billions of IoT devices, that address space quickly became exhausted. That's where IPv6 comes in. IPv6 uses 128-bit addresses, which expands the number of possible addresses to about 340 undecillion, an unimaginably huge number, more than enough to support the internet's growth for the foreseeable future. Now let's look at the key differences of IPv4 and IPv6. First, the most obvious difference is the address size. Second, IPv6 has a simplified header structure compared to IPv4. This makes packet processing more efficient and improves overall network performance. Third, IPv6 was designed with security in mind. It integrates IPsec as a standard feature, which means stronger encryption and authentication capabilities than IPv4. And finally, IPv6 supports stateless address auto-configuration. This allows devices to configure their own IP addresses automatically without relying heavily on manual setup or DHCP servers. So overall, IPv6 offers more addresses, improved efficiency, built-in security, and easier configuration compared to IPv4. Since most of the internet still runs on IPv4, the migration process is slow and gradual. To bridge the gap, three main transition strategies are commonly used. The first is dual stack. This allows devices to run both IPv4 and IPv6 at the same time so they can communicate using whichever protocol the other system supports. The second is tunneling. In this method, IPv6 packets are encapsulated inside IPv4 packets so they can travel across older IPv4 only infrastructure. This lets IPv6 networks connect with each other even if the path in between isn't fully upgraded yet. And the third is translation. Protocol translators make it possible for IPv6 only devices to communicate with IPv4 only systems, ensuring compatibility during the transition. Together, these strategies allow us to maintain backward compatibility while gradually moving toward full IPv6 adoption. To sum up, IPv6 solves the limitation of IPv4, especially address exhaustion. This topic is crucial in networking and communications because the internet is constantly expanding and IPv6 ensures we can keep growing without running into limits. Thanks for watching.